Hello everyone. Six Sigma, DMAIC and DMA methodologies are essential for enhancing quality. While DMAIC improves existing processes by identifying and reducing defects, leading to more consistent quality, DMADV ensures new products or processes meet customer needs and quality standards from the start. In this presentation, we will first see the history and origin of the Six Sigma. As we all know that Six Sigma is a data-driven methodology for eliminating defects and improving processes. It was pioneered by the Motorola in the 1980s to improve its manufacturing processes. Bill Smith, a Motorola engineer, is often credited with the development of this methodology. In the 1990s, Jack Welch implemented Six Sigma at General Electric, contributing to its widespread adoption. The success of Six Sigma at GE helped it become a global benchmark for quality improvement. Over time, Six Sigma has evolved to apply to various industries beyond manufacturing, including healthcare, finance, and IT. Let us first see the definition of Six Sigma. Six Sigma is a data-driven methodology for eliminating defects and improving processes. It focuses on reducing process variability and enhancing quality. The term Six Sigma refers to a statistical measure that represents near perfection with only 3.4 defects per million opportunities. It utilizes various tools and techniques to achieve operational excellence by consistently meeting or exceeding customer expectations. Here are the key principles of Six Sigma. First, customer focus. That is, voice of the customer. Every Six Sigma project should aim to improve customer satisfaction by understanding and meeting their needs. Second, data-driven decision making. Decisions should be based on the robust data and statistical analysis, not assumptions. Variation reduction. One of the primary aims of the Six Sigma is to reduce variation in the processes to improve consistency and predictability. Next is process-centered approach. Six Sigma views a business as a collection of processes that must work harmoniously. Proactive management. Six Sigma identifies and addresses potential problems before they escalate into defects or failures. Collaborative teamwork. Six Sigma encourages cross-functional collaborations to achieve goals and implement improvements. Methodologies of Six Sigma. Six Sigma primarily follows two structured methodologies, that is, DMAIC and DMADV. DMAIC stands for Define, Measure, Analyze, Improve, and Control, while DMADV stands for Define, Measure, Analyze, Design, and Verify. DMAIC methodology is a structured Six Sigma methodology focused on optimizing existing engineering processes. DMAIC employs a systematic approach using statistical tools to identify inefficiency and eliminate defects. Each phase define, measure, analyze, improve, and control in DMAIC methodology ensures that improvements are sustained over time. DMADV methodology. DMADV methodology is a framework tailored for the design and development of new engineering processes or products, emphasizing the creation of high-quality, defect-free systems. This methodology ensures that engineering solutions are data-driven and aligned with customer requirements. The 5 phases of DMADV methodology, that is define, measure, analyze, design, and verify, guide teams to ensure that new systems are efficient and reliable from inception. Now we will discuss in brief about different DMAIC phases. The first phase in DMAIC is define phase. Define phase in DMAIC sets the foundation by clearly identifying the project scope, goals, and customer requirements. It involves defining the problem, project objectives, and key deliverables to ensure alignment with stakeholder expectations. Key tools in the define phase are project charter, which outlines the problem, goals, timeline, and roles. CPOC diagram, suppliers, input, process, outputs, customers. It maps the high level process and helps identify critical elements. Voice of customer. It captures customer needs and expectations, critical to quality tree. It breaks down the customer requirements into measurable quality attributes. The second phase in DMAIC methodology is measure phase. In the measure phase, the focus is on quantifying the current performance of the process by establishing baseline metrics and performance standards. This involves collecting accurate data to understand how the process is performing and identifying key metrics that will be used to assess the improvement. The important tools used in measure phase are measurement system analysis, control charts, Pareto analysis, quality function deployment, that is QFD, and benchmarking. Third phase in DMAIC methodology is analyze phase. In the analyze phase, the goal is to identify the root causes of defects or issues by thoroughly examining the data collected during the measure phase. This involves analyzing the data to uncover patterns, trends, and relationships that may contribute to the problems. Important tools which are used in analyze phase are fishbone diagram, Pareto chart, hypothesis testing, root cause analysis, scatter diagram, and regression analysis. These tools collectively assist in understanding the underlying issues and guide the development of targeted solutions. Next phase in DMAIC methodology is the improve phase. In the improve phase, the focus is on developing and implementing solutions to address the root cause identified in the analysis phase. The goal is to make targeted changes that will eliminate or significantly reduce defects. The major tools used in the improve phase are design of experiments, pilot testing, failure modes and effect analysis, Kaizen, and value stream mapping. Next phase is control phase. The control phase ensures that improvements made in the improve phase are maintained over time and that the process remains stable and effective. Important tools used in control phase are control plans, statistical process control, standard operating procedures, and process audits. Please like, share, and subscribe to our channel to keep us motivated in creating more amazing contents. The next methodology in Six Sigma is DMADV methodology. This methodology is used for designing new processes or products that meet customer needs and process performance levels. When to use DMADV? As we know that for new processes or major redesigns of existing processes. The key characteristics of DMADV methodology are that it focuses on defining goals, measuring critical factors, analyzing alternatives, designing new processes, and verifying performance. DMADV phases. The first phase in DMADV methodology is define phase. The objective of the define phase is same as in DMAIC methodology. Clearly define the goals, scope, and requirements for the new processes or products. The important tools which are used in define phase of DMADV methodology are project charter, CPOC diagram, voice of customer, risk assessment matrix, and process mapping. Next phase in DMADV methodology is measure phase. As in DMAIC methodology, the second phase was measure phase. In DMADV methodology also, the second phase is measure phase. In this phase, we focus on gathering and analyzing data to understand the current state or establish benchmarks for the new process or product. This phase is critical for providing a clear and quantifiable understanding of what needs to be improved or changed. The important tools which are used in measure phase of DMADV methodology are measurement system analysis, control charts, Pareto analysis, quality function deployment, benchmarking, descriptive statistics, and data analysis. Third phase in the DMADV methodology is analyze phase. In this phase, the data collected in the measure phase is used to identify root causes of problems and potential areas for improvement in the process or product design. The important tools which are used in analyze phase are design failure mode and effect analysis, that is DFMEA, risk analysis, benchmarking, process analysis, and gap analysis. The fourth phase in DMADV methodology is design phase. Objective: to develop and design the new process or product based on insights from the analyze phase, ensuring that the developed product or process meets the identified requirements and performance standards. The basic tools used in design phase are CAD software, simulations, prototyping, design of experiments, and design review. The last phase in the DMADV methodology is verify phase. The objective of the verify phase is to test and validate the new design to ensure it meets the specified requirements and performs as expected before full-scale implementation. The important tools which are used in verify phase are pilot testing, process capability analysis, validation testing, implementation planning, training and documentations, and post-implementation review. With the help of this small case study, we will try to understand how DMADV methodology can be used or utilized for a new smartphone model for a consumer electronic company. In define phase, we can identify the need for a new smartphone model based on customers' feedback. While in measure phase, the defined performance standards for battery life, screen resolution, and durability can be tested. In analyze phase, we can develop and evaluate several design alternatives. While in design phase, we can create detailed designs and prototypes of the new smartphone. In verify phase, we can conduct extensive testing to ensure the product meet all design specifications and customer expectations. The result could be successful product launch with high customer satisfaction and increased market share. Comparison of DMAIC and DMADV methodologies. Similarities and differences. We will first see what are the similarities and differences in objectives of both the methodologies. So both the methodologies aim to improve quality and performance. Application areas. There is a slight difference in application areas of DMAIC and DMADV methodologies. While DMAIC is used for improving existing processes, DMADV methodology is used for designing new processes or products. Key phases. Both methodologies have a define and measure phase common, but they differ in their approach to analyze phase, improve or design phase, and control or verify phase. Please like, share, and subscribe to our channel to keep us motivated in creating more amazing content. Thank you.